The tree, a prefix tree. It's a tree built out of characters, and it can hold an entire dictionary in a single shape. Its superpower is sharing. Every word that begins the same way shares that beginning, stored exactly once. That's what makes it lightning fast at anything to do with prefixes, autocomplete, spell check, word games. Let's build one, with no code, just pictures.
Here's the idea. Start from the root at the top, which spells nothing. Each edge going down carries a single letter, and the path you walk from the root spells out a word. Follow C, then A, then T, and you've spelled cat. Follow C, A, R, and you've spelled car. One more step, D, and you've spelled card. 3 words, laid out as paths through one tree of letters.
Now look closely at how those 3 words begin. Cat, car, and card all start with C, so they don't each get their own copy of that beginning. They share it. The C edge and the A edge are walked once, then the paths branch. Store 1,000 words that all start with the same few letters, and that common start is stored a single time. That shared prefix is the whole point, and the reason it's called a prefix tree.
But a path by itself isn't enough. Walking C, A lands you on a real node, yet CA is not a word, it's just on the way to cat and car. So every node carries one extra bit of information, an end-of-word marker, a ring that says, a real word ends right here. Car has the ring. Card has the ring. The node at CA does not. Without that marker, a tree couldn't tell a finished word from a passing prefix.
Everything a tree does is built from 3 little moves. To insert a word, walk its letters from the root, creating any link that doesn't exist yet and reusing the ones that do, then light the end ring. To search for a word, walk its letters and check for that end ring at the finish. And to test a prefix, starts with walk the letters but skip the ring check, you only care that the path exists. Insert, search, starts with 3 moves. Let's put them to work.
Problem 1. Implement the tree. Support 3 operations, insert a word, search for a full word, and starts with, which asks whether any word begins with a given prefix. We'll insert cat, car, and card to build this tree, then run a few queries and watch exactly how each answer is decided.
Insert already laid down the paths, reusing the shared C, a stem, and branching out to T, R, and D. Now search for car, walk C, then A, then R, the path is there, and the end ring is lit, so car is found. Now search for CA, the path exists, but there's no end ring on that node, so CA is not a word, search fails. Finally, starts with CA, walk C, same path, but this time we skip the ring check. The path exists, so yes, words do begin with CA same walk, one different question at the end.
Problem 2 adds a twist. Add and search words, where the search can contain a dot, and a dot matches any single letter. So a query like C, A, dot should match any real word that is C, A, and then anything. How do you search a tree when one position could be any character at all?
Walk the fixed letters exactly as before. C, then A. Now you hit the dot. You can't commit to one branch. A dot matches anything. So instead of choosing, you try every child at once. From the CA node, follow T down to cat, and follow R down to car. Any branch that lands on an end ring is a match, so both cat and car answer yes. The dot simply forks the search into all available directions. That branching out is exactly what recursion is for.
And now the boss, word search. You're given a grid of letters and a dictionary of words. Find every dictionary word you can spell by stepping between neighboring cells. Search each starting cell blindly and the paths explode into millions of dead ends. The fix, pour the whole dictionary into one tree and let that tree steer the search, only ever walking directions that could still become a real word.
The dictionary here is our 3 words, cat, car, card packed into the tree. Now walk the grid, keeping a finger on the matching tree node. Start on C. Step to A. C is a real prefix in the tree, so keep going. Step to R, that spells car and end ring a match, and on to D, which spells card another match. Back up to A and step to T instead, that spells cat a third match. But now try stepping from C to Z. The tree has no Z link off the root. No word starts with CZ, so we prune that branch instantly and back out, never wasting another move. The tree turns a hopeless, exploding search into a guided one.
That's the tree. One tree of characters, where shared beginnings are stored once and an end ring marks each real word. From that single shape came three powers: prefix search, by walking letters and checking the ring; wildcard search, by forking at a dot into every branch; and grid search, pruned fast by a shared dictionary. Whenever a problem is really about prefixes or shared beginnings, reach for the tree.
This is pattern 7 of 18. Learn every one, plus hundreds more lessons. Master code. Master your future.
CodeSamur-ai